Hey everyone, so I'm Aravind Narayanan, an applied machine learning intern with the engineering team at Vector. So today I'm presenting my project HumaniBench, which is a human-centered evaluation framework for multimodal large language models. So the main motivation behind the project is essentially that a lot of these models are technically quite accurate and powerful, but tends to lack on certain aligning with human values like fairness, ethics, and responsibility in general. And they tend to have societal biases as well in aspects of gender, race, and occupation, which have been quite popular in the recent times, especially in the case of models like Gemini, which had quite a bit of problems, which tends to skew the results. And we also noticed that not a lot of these models perform as well when looking into cultural elements and multilingual aspects, which is pretty important in terms of looking at it from a global inclusivity perspective. So therefore, to address this, we go into our project HumaniBench, which essentially is a 7-dimensional framework. Wherein we try to address a lot of these elements in terms of bias, fairness across various attributions and multilinguality. And for doing this, we present a novel 30,000 image data set, which has multilingual prompts, questions, and answers for all of these tasks, and are evaluated on over 10 state-of-the-art models, which are popular at the moment and are being widely used. As you can see in the table as well, there are different data sets in the past which address different aspects of these human values that I mentioned. But to our knowledge, we are the first, ours is the first evaluation framework that addresses all of these dimensions and unifies them into one particular suite, in a unified suite. So to be able to essentially do this, we look into the annotation pipeline first, wherein we use real-world images primarily from news media to reflect authentic demographic variation. And we make sure to exclude synthetic images in this. And we also have a 2-step annotation process, wherein first we have used GPT-4o to get meta tags for each of these images and also get captions. Then we use them to be able to categorize them into 5 attributes, which we found were quite important in terms of age, race, gender, occupation, and sports. All of this, once we assign them into these 5 attributes, we do a human review of all of the data, and then use them as a data set. So as I mentioned, we test our data on latest models by most of the major companies which are open source, with as latest as the Gemma 3 model, which came out just a couple of weeks before. Now, as I mentioned, we evaluate them on various elements. So we have 7 such tasks, and the first task here is on social attributes, wherein we try to give general questions across attributes and test them via a plane as well as a chain of thought format to evaluate how the reasoning depth is for different social contexts. Secondly, we focus on contextual understanding, wherein we look into creating image-specific questions to assess how well these models interpret subtle social and professional cues from appearance and setting of the image. Thirdly, we focus on visual recognition skills and see how well it performs by giving multiple choice questions on the observable content in the image. We have 4 more tasks. Wherein the 4th task is essentially to evaluate the model's multilingual capability and cultural understanding, where we test it on 10 different languages, wherein 5 of them are high resource languages, where we have more data available in terms of French, Portuguese, Spanish, etc. And we also assess them on 5 low resource languages like Punjabi, Urdu, Tamil, and so on as well, and compare the results with English as the base reference to see how well they perform. Then we look into the 5th task, which is the visual grounding task over here, the essential idea is to see if these models are able to locate the referred objects in the based on the questions that are being asked. So if the question is referring to a child over here, we see if it's able to identify the bounding box region of the image to essentially understand this facial capability. The sixth task is focused on emotional and human-centered answering ability, where we assess how well the tones are in the results and how they change by varying the prompt styles. We used a subset of our data set by selecting emotionally triggering images to be able to do this task. The seventh task is essentially on robustness and stability of the results and how they vary when you have image attacks like blurring, like minimal blurring, compression of images, region blackouts of certain random regions, and so on, and then test the ability. So these are the 7 tasks that we worked on, and we try to make observations based on that to see how the models perform. So when we look at first 3 tasks, which we see that the social perception and contextual reasoning still remains challenging for a lot of these models, and it varies by attributes. So we see in the cases of gender and race, wherein the performance is relatively lower, as opposed to cases like occupation and sports, where it seems to be performing better in terms of contextual understanding. Even top performing models like LLaMA 3.2, which is one of the most popular models, tend to have quite a high bias of close to 12% in gender and race in our particular data set, which essentially shows the need for more equitable model behavior in terms of different facets. So when we also, as I mentioned in the first task, we attempt 2 styles of prompting, wherein we attempt a simple prompting as well as we have a chain of thought reasoning method. We see that when we do a chain of thought reasoning and we make them reason like humans step by step and then reach to a conclusion, we see that the accuracy increases and the bias reduces as well. Then going to the next observation is in terms of multilingual capability and in terms of cultural understanding. So we see that a lot of them perform quite well on higher source languages like French, Portuguese, Spanish, etc., but don't perform as well in lower source languages like Bengali, Punjabi, Tamil, etc., which could potentially be because of data scarcity while learning, as well as models' limitations, which shows the need for more training in these particular areas. And we see that some models particularly perform well in low resource languages as well, like the LLaMA that I mentioned. Even though it has bias in gender and race, when we saw in the previous case, it performs quite well in low resource languages. And another interesting thing was that on an attribute level, it tends to vary, as in, like if you look at particularly in gender, on an overall basis, low resource languages, the variation is quite higher, which is potentially because of how these languages address and refer to genders in their language in general. So looking at that, it gives a better understanding as to how certain languages tend to have more bias or lesser bias in certain questions. Then, in the 6th task where I mentioned about detecting regions of interest, we see that the traditional detectors which don't use these vision language models tend to perform better, which you see in the bottom, which is the baseline, tend to perform better. But we see that the vision language models' spatial understanding skills are improving, but there is still scope for improvement in general. We do all of this without fine-tuning and see it on a zero-shot basis to see how well they perform. When we see that there is a requirement for fine-tuning when it comes to tasks related to this. And then we also see that so all of these models tend to rely more on the vision language alignment rather than identifying particular regions directly, which is how these models tend to work in general. Then we look into how well the model's answering styles vary by prompt. So the styles tend to influence how well the analytical capability or emotional capabilities are. So we see that different models tend to have different emotional signatures, and also that when we give empathetic prompts, we see a boost in both boost in the emotional tone, as you can see the difference in the second image, wherein the darker bar increases, which is in terms of the score for empathetic tone, when we give an empathetic prompt as opposed to a simpler prompt when asking questions. And the final observation is in terms of robustness. We see that even on slight perturbations like blurring and adding a bit of noise, we see that its ability to identify visual details degrades quite a bit, when it's not able to identify complex and nuanced situations. So therefore, we see a need for it to improve model resilience in general. So to conclude, we see that, as I mentioned in the start, a lot of these models are technically quite sound, but struggle with fairness and bias and human-centric values. And secondly, we see a lack of performance in lower source languages and spatial understanding, which highlights the ongoing limitations of some of these models. And using a chain of thought and empathetic prompt style and can essentially identify what the user wants, can help identify what kind of model to be used for their particular use case. And to conclude, for a summary for next steps, we are essentially trying it on larger scale models to see if this bias reduces and accuracy improves on all of these tasks. We want to compare them on closed source models like Gemini as well, Gemini and GPT-4o, to see how well they perform as compared to open source languages. And thirdly, we're at the moment compiling the results into a paper, which we hope to submit it at a ISTA conference. And that's about it. Thank you.
Really great overview, interesting work. I had a question about the data, and you mentioned that you had leveraged like a large set of images for this task. I'm wondering some of the ethical or logistical challenges with sourcing those images, both from the perspective of like, did you use open source or just like whatever images you could find? Did you care about that? And what challenges might that bring in the future? And then also, how did you identify or exclude synthetic images? And in the future, do you anticipate that that's going to be pretty straightforward to do? Or is there just like an established best practice to be able to do that? Or did you kind of make it up?
Sure. So to start off, the images were taken primarily, as you mentioned, from news media. As you can, a lot of them tend to have sources like RSS feeds and streams, wherein a lot of this data is public. Then we go through a filtering process wherein we blur out important details, personal details. It's a standard procedure in most of the responsible AI projects, wherein we tend to blur out personal information and all of that. There's a certain process that framework that we go through. And all of this is based on a compliance document for AI that's usually followed across the industry. That's sort of what we use. And for synthetic data identification, we use quite a bit of manual review for that at the moment. But we hope to essentially make a structured framework out of it so that it becomes easier in the future to essentially evaluate whether it's a synthetic image or a real image.
Yeah. Do you think there's a risk of like, for images that weren't caught manually, that there could be infiltration of, not infiltration, but like there could be synthetic images within the data set? And if so, in the future, would like a standardized framework or like something technical to drive that exclusion support having less of that in the data set? Like, do you imagine that at some point there was a couple of synthetic images that snuck in, and how do you think in the future we could address that better?
Absolutely. I think that's definitely a good point especially in terms of how the image generation capabilities of a lot of these models are coming up. It's quite an important aspect. At the moment, yes, to our knowledge, there aren't any in our data set in terms of based on the checking that we've done, because it was with a group of people and not just one person going through it. I guess, yeah, essentially in terms of developing a structured framework would definitely make things a lot more easier and a lot more transparent in terms of how this particular vetting is done, just so that it could be reproduced in the future for other tasks as well.
One other question, if it's okay.
Yeah.
How did you make sure across all of the tasks that you performed, all like very different and very interesting questions, that you had appropriate images to be able to answer each question from different perspectives? Because obviously like the news images, a lot of them are going to be of similar events or like similar people. How did you make sure that your data is like representative of different issues that you might encounter?
Yeah, that's a great point. In fact, that was one of our biggest tasks in the project, identifying what kind of tasks we do and also what kind of images that we select for it.
Yeah.
Like in terms of emotional tone, as I mentioned, we selected 1,000 potentially emotionally significant images in terms of positive or negative. Exactly. So all of these images, for each of the tasks, we haven't used all the 30,000 on each of them. We've used a subset of them for each of the tasks, which we think would potentially trigger those questions. So that's sort of how we went about, and that was done manually because we wanted to identify when I mentioned image specific questions, we needed to make sure the image was potentially relevant enough to answer those type of questions. Otherwise, there's no point in terms of what we're trying to accomplish if it's just random images. So we made sure we used a subset of these images for each of the tasks relevant to a particular use case.
Yeah, I think there's a lot of interesting work that could be done to like establish criteria for what data would be needed to like answer these questions. And so like obviously you're pending publication and stuff, but I think like that would be a really interesting research question to answer. Looking forward to seeing what comes of it for you.
Thank you.
Thank you.